Hello, everybody, and thank you for joining us today. My name is Mike Kopczynski, and I'm here with my colleague Jeff Tufts from Cisco's Utility Sales and Solutions team. We're excited to welcome you here today to today's webinar. We'll be exploring some very timely topics in utility cybersecurity and compliance. Over the next hour, we'll cover some important regulatory updates, share best practices for managing cybersecurity risks in substations, and review how Cisco solutions can help you stay compliant and secure. We're excited to be joined today by industry experts from 1898, part of Burns McDonnell, as well as our own specialists from Cisco. So let's take a quick look at today's agenda. First, Eric will provide an overview and updates on some of the NERC CIP regulations and what they mean for you and your organization. Next, John will dive into some best practices for monitoring cybersecurity in substations, focusing on both architecture and process. Finally, Marcus will walk us through how Cisco's solutions can help you achieve compliance, monitor for threats, detect incidents, and remediate issues efficiently. We encourage you to ask questions throughout the session using the Q&A panel, and we'll address as many as possible during the session. Stay with us to the end, and we'll be providing some resources to help you take the next steps in your journey. So without further ado, I'm going to hand it over to Jeff Tufts to kick us off.
All right, thanks, Mike. Thanks, everyone, for joining. Great crowd today. Just to recap, as Mike said, we're gonna, with respect to what we hope you get out of this. So we certainly hope you get the what and what's changed pretty recently from Eric with respect to CIP-015, which obviously is the main thread for today. 1898 has been at this for quite some time, helping utilities get ready for this moment. And so we're going to hear from John. And we're really going to learn about lessons learned as they've dived into helping utilities across North America get ready for this. So they have some really compelling empirical evidence of what the right way to do things and so forth. And finally, Marcus, as Mike said, is going to come in and give us a little bit of, what is this defensible architecture and what if your existing Cisco investments can be used to kind of achieve some of this. So throughout today, we're going to be using something called Slido. And so kind of have a sample one should show up on the side of your screen here. Oops, sorry, my bad. And so, right, I can't see it, but Mike, if you could read it, because I can't actually see it on my side. Mike?
I'm not seeing it either right now.
The question is, what percentage of data breaches involve human error?
Great, thanks. Yeah, and so just trying to get everybody comfortable with the usability of Slido, which is one of the plugins here for WebEx. So, essentially, as that comes in, you'll get no sense, or it's no surprise to you that depending on the resources you look, it's often above 90%, which in previous webinar series, you've heard us talk about automation. It's one of the reasons automation is taking the OT world by storm, is not only are the breaches largely caused by human error, but so are the network outages. And so that'll be a bit of a thread we'll pull on throughout today, but appreciate you being able to dive into that. So with that, let's dive into it. So, as Mike said, we are just super thrilled and fortunate to have 1898 with us. We've worked with Burns McDonnell for probably coming up on 20 years together, and to have 1898 part of their consulting arm, come together with us on this important topic is pretty great. And so Eric and John are going to be doing the lion's share of presenting from the perspective of 1898. And just between the two of them, we were talking right before this call, between the two of them, we got a half century, and between the other folks on the call that have been presenting, we're approaching 150 years of people that have been doing OT networking. So we're super thrilled to have our guests today. So Eric leads up the consultant cybersecurity compliance piece of Burns, I should say 1898 within Burns, and he's going to kick us off, as I said before, just giving us a NERC CIP-015 review, and then John, offering director for the endpoint security and risk, consulting practice at 1898 is going to take us another level deeper on talking about architectures and lessons learned as they've been navigating this in concert with their utility customers. So Eric, I'll pass it off to you.
Thank you very much, Jeff. So why does CIP-15 matter? That's why we're all here, right? Little background. North American Electric Reliability Corporation, for those that aren't familiar with NERC, is responsible for ensuring the reliability and security of the bulk electric system across North America. They were anointed by Congress in the Federal Power Act of 2005. FERC appointed them the Electric Reliability Organization. So they have the responsibility of developing mandatory standards to ensure reliability of the electric grid. So about 2007, they determined that there needed to be critical infrastructure protections as well. So we needed to protect the cybersecurity portion of the grid, not just operations and planning pieces. So that was established to create some cybersecurity requirements as well. Why is all of that important? Why does it matter that that NERC has established these standards and require them for compliance? Well, the big issue is, and what gets everybody's attention, is that failing to follow them could result in fines of up to $1 million per violation per day. So not only do we need and want to keep the electric grid secure and running, we want to keep our facilities up and running to protect our investments individually as well, but there are regulatory fines involved in this as well. So the risks involved in this are pretty substantial from a number of perspectives. So why CIP-15 now? Why all of a sudden, right? So previously, network security, as it was originally designed or as originally outlined within the CIP standards, focused on protecting the environments around the electronic security perimeter. And the electronic security perimeter was defined by usually a firewall or a router, and that would route all traffic through a single electronic access point, right? So that was considered the primary protection. All north-south traffic was taken care of. However, there was no requirement to monitor east-west traffic. Nothing was happening at that point. And as a result, we saw in 2015 in Ukraine, there was a huge incident where bad actors got access into the environment. They were able to navigate east-west throughout the environment at will, create credentials, administrative credentials for themselves, wreak havoc, and impact a very, very large utility and something around the scale of 275,000 users for a period of days that went dark because nefarious actors were able to get in and navigate east-west within the environment. So, so why? What is INSM? What is internal network security monitoring? Why is east-west important? As we talked about, as I mentioned just a moment ago, east-west navigation within the environment is incredibly important. We can protect the perimeter all we want. We can instruct our users on how to be more diligent about recognizing phishing emails or other types of things getting into our environment. However, once something is inside the environment and is able to navigate laterally throughout the environment, we have no way to control it at this point. So internal network security monitoring provides us the continuous visibility inside the OT network, also able to provide some rapid identification of those unauthorized or suspicious activities. So we're able to identify and act on those things quickly and more effectively than instead of finding out after we've been breached and huge unexpected outage happens. So our key benefit here to implementing internal network security monitoring is proactive threat detection before the damage occurs, right? So we want to make sure that we're able to keep the bad guys out from the very beginning. So the way CIP-15 is structured, right? It shifts focus from perimeter defenses to internal network security. And I shouldn't say shifts it completely, but it shares the focus, not and taking some of it off the perimeter, but puts it into internal network security. So the real-time monitoring of network traffic within your OT environment is really what we're looking to achieve here. Understand what's happening within the different the different aspects of the network, the different segments, the different VLANs that might be within your environment. And then we're going to build resilience through anomaly detection and forensic capabilities. That's really what's going to happen here, right? So resilience is the point. That's really what we want to get to. Security is desired, but security, there is no such thing as 100% security. So we have to develop resilience into this as well, and this is going to help us build that. So with CIP-15, now that it's a standard, now that it's been approved by FERC, just this was about 10, 14 days ago, I believe it is, something like that, on June 26th, FERC actually approved the current version of CIP-15 with a caveat. They approved it with the caveat being that they wanted to include ECMs and PACs, physical access control systems, and access control and monitoring systems as well. So the initial version of CIP-15 drafted by the NERC standards drafting team did not include the electronic access control and monitoring systems or the PAC systems. So FERC has said, this is great, include those as well, and we'll be really good. So waiting for the word back at this point now, whether the standards drafting team is going to revise the language in the current version before it becomes effective on October 1st, 2025, or else adopt it as it is, commit a SAR, and stand up the drafting team to do a CIP-15-2 right away to be adopted prior to the October 1st, 2025 effective date. So that said, with it being approved by FERC in June, it makes our effective date October 1st. On the timeline you see on the bottom there is a T0 date. That's the October 1st, 2025. That's when it goes into effect at that point. From that point, the implementation plan is given 36 months or 3 years from that date. So October 28, all control centers and backup control centers, whether they be high or medium impact with ERC, are required to be compliant with CIP-15 at that point. That means you need to have your internal network security monitoring in place, collecting data and protecting the data that gets collected from that in place at that time. Then there's an additional 24 months for all the rest of the medium impact with ERC assets to be compliant. And at that point, October 2030 is required that everybody be fully compliant. So that said, we know
Hey,
we have
Eric,
to be compliant.
I wanted to just circle back on that last slide for a second,
Sure.
just get your thoughts on that. I think you
Yeah.
alluded to it, but you know, there's no application of this ruling under low impact, and that's
Correct.
not uncommon. And I wonder if you could talk empirically just a little bit about rules that have first come out, whether it was the bulk electric system or whatever the verbiage was. Talk a little bit about what you've seen in your career if these rules come out, and usually very much focused on the bulk electric system, and whether or not that trickles down elsewhere.
Sure.
What your expectations? I know you don't have a crystal ball, but what your expectations are here.
Well, I don't have a crystal ball, but I have seen and have kicked around this industry and NERC compliance long enough to know that they start at high and medium impact, and they slowly trickle their way down to low impact, and they trickle their way into other critical infrastructure as well. some of that being water systems, gas systems, transportation and the like as well. So we will start to see this push out into other industries. But as far as the low impact systems go at this point, it's not there, because it is deemed to be a pretty onerous undertaking for the smaller low impact utilities or BES cyber systems facilities to have to undertake at this time. That being said, as was the case with the transient cyber assets that originally weren't part of the low impact program, became adopted. And then the next most recent coming version of the low impact standards is going to include some other additional pieces as well that were first adopted at high and medium impact. So it's coming. It will be there. It's likely to be that we'll see it roll out in a lighter format. We may see it adopted in a different way. It's not going to be adopted as CIP-15, but it will have some watered down pieces coming out to low impact. I would assume when we see how effective it is, how it gets applied and how it gets adopted in the next 5 years, we'll probably see it start to trickle down a little bit to low impact.
Yeah,
but that said,
I think we have the same expectation, and how to do that at scale is going to be one of the challenges, and I think we'll touch about that a little bit with John.
And one thing to mention about that too, and I know John and you guys are going to probably touch on this a bit more also, is that there are a lot of entities out there that have mixed impact environments. They have high impact control centers, maybe some medium impact transmission sites, maybe a medium impact generation site, and a whole lot of low impact generation sites. And in that mixed environment, it's not always easy to say, okay, we're going to only adopt this just at medium impact. Those OT networks don't always just stop at the edge of where that impact is. So being able to roll out this type of functionality and include your low impact assets as well is only something that's going to benefit your organization as a whole, because again, it's not just about the compliance, but it's about the security, resilience, and integrity of the bulk electric system and our own facilities as well. Because even though we have compliance requirements, anytime you have to take an outage because of something that's happened like this, because of a compromise, can be hugely impactful. So if we can avoid that with some investment in some best practices and some secure thinking, it's a win all the way around.
Yeah. Okay. Thanks, Eric.
Absolutely. All right. So with that said, and this is a great segue into what are the steps that we need to take towards compliance, right? So first things we need to do as we're thinking about this, and the reason that we have a 3-year lead time to having to be compliant is because this is not something that is a drop in place. We're not just going to throw some hardware or maybe some software at this, turn it on, let it run, and it's going to take care of it, right? So we need to actually put some thought into developing a process for internal network security monitoring, right? And that process needs to include risk-based monitoring, anomaly detection and response, data integrity and retention. It's got to include those 3 things. We're going to do the monitoring. We're going to detect if there is an anomaly and take an action on it. And then we're going to protect that data once we've collected it, right? So we have to develop that process. We've got to establish that method for capturing that monitoring data and the anomalies that are detected. And then we have to enhance our protection methods to ensure that data is secured on the back end, just as we would BES cybersecurity information. Any BES CSI, we would definitely be protecting that in the same way. So we're gonna do the same with this. So yeah, So that's essentially what we'd be doing for getting ready for the compliance. And in terms of that, the next pieces then would start to look at the technical pieces, how to set that up from a technical perspective. And for some of those best practices, I turn it over to John.
Yeah, thanks, Eric. As John's kind of getting ready, I want to just recap a little what we heard today. One is, now's the time where we really need to be focused on this. The clock has started to get into compliance, and there's always, the $1 million per event fine that's kind of sitting out there. And you talked about how it's the steps we got to go through. It's not necessarily super simple, but it's definitely worth it, and it definitely increases the safety and reliability of our grid. So it's a really important task for us to take on. And I think that's, a great segue to John to kind of tell us some best practices and how we actually implement that to achieve those results.
Right. Thanks very much. I'll go ahead and get started here on talking about these best practices and how we're going to kind of work on the actual technical architecture for CIP-15 related implementations and INSM in general. So what I have up here is sort of a simplified network diagram for what a typical substation might look like. You typically have some levels there. You might have a station level, bay level, and process level for your equipment, which covers various things from SCADA all the way down to sensors and things like that. So you have a set of devices there. I have a red dashed line across the middle. That's the ESP, so the electronic security perimeter, which is your boundary for a NERC CIP related medium or high impact network. The orange firewall there in the middle is sort of what would end up being your electronic access point. And if I'm drawing this for like a CIP compliant diagram, I'm probably putting that firewall on that line so you can see that's sort of the boundary. But for cleanliness, I kind of kept it in line above there for this depiction. So typically, as Eric kind of alluded to already, our traditional protections focus on perimeter defenses, which covers a lot of north-south traffic. So you kind of see the orange line on the left there showing that, traffic either coming into or leaving that network is what we have a lot of controls over at this point. That's all well and good, and it's still something we need to do, and it's something covered in CIP-5 as far as what you need to do to accomplish that. But what we're missing is the traffic traversing the internal network there, or the east-west traffic, which is represented by the blue line at the bottom and those blue switch icons in the middle of the network there. So essentially, those are the area of concern for this particular requirement. This is a substation example on the screen here as far as what this diagram is showing, but it also applies to control centers as well. Obviously, there's a slightly different layout there, but you might have multiple networks dealing with various pieces of your control system in that control center that that would have a similar kind of idea, would have similar ideas of having EAPs, electronic access points, for ingress and egress, things like that. So if you've been involved in CIP compliance for a while, you probably have a good handle on that, right? How the perimeter defenses are protected. You have your CIP-5 R1 requirements for establishing that ESP, having your electronic access point, requiring that all inbound and outbound access permissions are controlled, and you're denying all other access by default. If you're in a control center, you probably also have additional requirements around CIP-5 R1.5, which is the requirement to have some method for detecting malicious communications for inbound and outbound communications. So you might already have something in place in a control center that does some level of monitoring for malicious communications, but it may not extend into the traffic within that network or within that ESP. One thing to note also is this requirement does focus on cyber systems that have external routable connectivity, meaning you have traffic that goes in and out of that network. In some cases, you probably don't have control centers in the situation, but you might have a substation that does not have ERC. So you might have a substation that is, for all intents and purposes, air-gapped. CIP-15 does not apply to that type of requirement, that type of system. So if you have those, they would be exempt from this requirement. So why do we even care about this? What is important about east-west traffic? Why is this something that NERC and FERC have decided to focus on in this new requirement? Well, the idea here is that we want to understand what is going on in that network to be able to look for potential malicious communications or other potential bad actors that might be able to access some of those systems and work within that network without then going through the firewall in a way that the firewall would detect that traffic. So let's say you have one of the devices here, maybe a relay on that bay level. It communicates with an HMI on the station level, but that traffic never traverses the firewall. It basically, it's just between those two devices within the network. It never goes anywhere else. If there was some kind of a compromise to one of those devices, let's say someone had applied some kind of malware to that HMI, and then it's going out and spreading it to other devices within the network, but never trying to get out of that network, the firewall might never see that malicious communication. So you might not be aware that that infection has happened and is spreading. Some of your CIP-7 related controls for malware protection might catch it if it's on a system that has malware protection on it, but not all those systems in these environments tend to have malware protection loaded on them. They rely on the network protections to cover a lot of that. So we might not see that spread if it doesn't hit the firewall. Another potential issue there could be if somebody, an actual intruder, whether we're talking physically, someone walks into the substation, or electronically through some remote access method is able to get into that substation network. If they're able to sit on one of those devices and then, gather reconnaissance, collect data, exfiltrate data, things like that, we might not see that if they aren't then going back through the firewall to get out. So being able to see what's going on within the network is valuable to that point. Third example, this one's a little anecdotal because I don't have all the details on it, but let's say you have a device. I heard of an example where someone shipped an inverter into a network that had a backdoor built into it. I'm not sure if that is necessarily a very likely situation, but let's say that could happen. If you have a device that has something built into it that is able to gather information and phone home, you might not catch that without being able to look at the network traffic around the network. So those are sort of the justification for this. Why, from a technical perspective, why do we want to focus on this particular area? Now, what do we do about that, right? So if we understand we need to monitor east-west traffic, where do we go with that? So we need to have some methodologies for identifying and prioritizing where we're going to monitor the network. If you've looked at the technical rationale for CIP-15, so NERC publishes sort of what this is about, why they're doing it, what things you need to focus on. There's actually an interesting thing in there that there's a quote from a book in there. They're quoting a book called The Practice of Network Security Monitoring by Richard Baitlick. And basically it says that monitoring is most effective when collection occurs at strategic network locations and utilizes a variety of methods. So kind of share what the reasoning here is. We want to understand the network and how we're going to traverse that. So looking at the diagram here, put a couple of little green magnifying glasses on there, covering the idea that, okay, well, we want to look at the traffic going through these switches. It's probably a good place to start. So if we have all of our devices connected to a set of switches, that's probably a good location that we want to start looking at our network monitoring. There are certain situations where that may or may not make sense. Let's say the switches are unmanaged switches, right? They don't have any capability to really do any monitoring at them. Things like that. Maybe we need to have something separate to handle that analysis if they don't have that capability. If they do, let's say you have a switch that has a fully managed switch with a lot of capabilities on it, can do some monitoring on its own and maybe phone home to a centralized monitoring system, then maybe that switch is the right place to start with. A lot of switches have things like span ports or mirror ports where you can go and duplicate the traffic and send it off to another sensor to do the analysis on. You can also use physical means like a network tap. They can go in and duplicate the traffic without actually being tied into the switches. So basically you want to have an idea of what is the capability within those networks and where it might make sense to put some sort of monitoring in place. So the requirement does allow for a lot of different choices for this type of technology. I mentioned a couple already, like taps and mirror ports, things like that. You can use NetFlow. So if you have a device that supports NetFlow, you can use things like if you have a software-defined network, the software-defined network capability, being able to develop that has its own monitoring capabilities built into it. So something like that could potentially be used. You can do things at the endpoint level as well. And they actually allow in that technical rationale, they have a line item that basically says other technologies. So basically allowing the open door for future solutions that might come out that might do this in a different way. You do also have to think about, as you're doing this, the sprawl you might be creating, right? So the idea that if I put something on every single switch in every single environment, am I going to have hundreds or thousands of devices to monitor, or devices that are going to be reporting back in? So you have to think about doing this in a reasonable way that will give you the visibility you need without necessarily overwhelming you with data. So that's something.
John, I'm just going to have to be timekeeper and see if you could dive into. I know you wanted to talk about sort of the considerations around tools and so forth, just to keep us on time. My apologies for interrupting.
Oh, no problem. Understood. I'll move forward here. Just one last thing to mention on this slide, just also, is the things that are out of scope. You do want to keep in mind that this is really looking at network traffic, serial communications, 420 milliamp circuits, those kinds of things, and WAN circuits are generally not in scope for this. You're probably going to be monitoring at the local network itself as opposed to those other types of connections. All right, so moving on here. So tool selection. So first thing you want to really look at is your selection requirements, right? So every environment's a little bit unique, but these are some things you could probably start with. You want to look at what your OT environment looks like, or your substation environment, or your control center environment, how it's different from your IT environment. It might be tempting to use some kind of an IT-based solution if you've already got a corporate IT network monitoring solution in place that is working for your corporate environment. It might be tempting to extend that into the OT side. It might work. It might be a good fit for you, but if it's not, maybe there's requirements around that IT network that don't exist in your OT, or it might not be compatible with the platforms you're using. You might need to look at something more OT centric, or at least has an understanding of what an OT environment looks like. You also need to think about what that solution is going to do in terms of, is it going to have any negative impacts to latency or performance of your network, or is it going to actually impact things? If you have a tool that can actually block traffic, is that going to disrupt your operations if it finds something that it thinks is malicious? Does that solution understand the processes that exist within your OT environment? Do they understand OT applications and protocols? If it sees traffic that is running on the correct port for DNP3, for example, does it know what good DNP3 traffic looks like? And that's a potential area where you might want to look at a tool that has that capability. And are your existing processes compatible with the solution? So a lot of companies do have very robust plans for how they monitor their firewalls. If we're now adding dozens, hundreds, thousands of additional sensors that are reporting back in, will your existing operational processes be able to account for that and be able to monitor this new traffic coming in? Because you can't just put the sensor in and just leave it alone and forget about it. You actually have to do something with that data, as Eric kind of alluded to earlier. And then again, evaluation criteria, digging into it more specifically. Once you have an idea of what type of solution you're looking for, you would want to go and evaluate those different tools, or we can help you do that kind of thing where you go through and do a bake-off of the various different tools that exist that might meet your requirements. Here's a couple things that you might want to look at. I mean, and this can vary based on the goals and the requirements that you might have, but if you're looking at what platforms, where it's going to be deployed, whether it supports monitoring the devices that you actually have, whether it supports the status of the individual assets within your network, protocol support, things like that, whether it can handle how it collects data, how it does baselining, which I'll talk a little more about that in a second, and then how its discovery process works. A lot of these tools have additional capabilities beyond just looking at the pure network traffic, and you might want to take advantage of some of those features, such as things like looking at patch level detection, understanding what devices on the network, what levels they're at, whether there's any vulnerabilities in those devices, things like that. And then you have the type of anomaly detection, which again I'm going to dig in a bit more. Whether it's some kind of rule-based or signature-based type of tool versus behavioral-based. Whether the tool has anything that specifically says it supports compliance. I mean, one thing I want to be very clear about in this is that if a tool or a solution or a vendor tells you that they are, NERC CIP certified or something like that, that's not real. So be careful with anyone who kind of makes that kind of claim. They can certainly have a tool that will, or a solution that will help support your compliance needs, but they can't really make the claim that they are, NERC CIP certified. There is no such certification. And then also integration support. You have other tools in place. How does this tie in with what you're doing? How does it work together with the other technology solutions you already have? So, you know, you go through that process, you figure out your solution, and you deploy it. That takes what, a week or so, right? Or probably more like months and years to get through this process, right? But let's skip over the actual deployment process because I feel like that could be its own topic for its own hour-long session. And let's go to the point of you've actually got a tool in place and deployed. What you have to do next. You need to have a good baseline, and let's talk about what a baseline really is. A baseline is a template for your normal behavior on a network. So you don't want to have a baseline that is a point in time of like a day, right? Let's say you monitor the network for a day and say, okay, we're good, and you turn on all the actual monitoring processes of that tool. That might not be very useful to you because you're going to get a lot of false positives. You probably have periodic processes that run maybe weekly, monthly, quarterly, even that you might not catch in that single day. So you want to make sure you have a good handle on what normal looks like before you go turn on all the alerting and overwhelm yourself with false positives. I mentioned signature-based versus behavior and machine learning-based. The idea being here is that some things work like a traditional antivirus tool where it gives you a very static signature of what malicious traffic looks like, and it just looks for that exact signature everywhere it goes. Behavior-based actually looks at that normal and tries to look for deviations off that normal and see where things look like they actually potentially could be malicious in a more unique way. And then we also want to identify any kind of indicators of compromise. That's another piece of that. So we'll look at that a little more in the next slide here, but the idea being that looking for what potential indicators of compromise might be out there is a good way to kind of tune your tool to look for the things that are most relevant to you.
John, I just wanted to add a point that emphasizes what you said with respect to signature and behavior. And I think Ukraine was mentioned before, and if anyone hasn't seen the YouTube video of the poor folks that are watching their cursor move around the screen, and I think that's a perfect example of what ties some of this capability around is opening a switch is certainly something you should do from an HMI. Opening 15 switches in 30 seconds is anomalous behavior, right? And so I think that really identifies having a baseline of actual behavior, and then being able to analyze that behavior against something that has an awareness of what's happening in the physical system versus just protocols and so forth. So I've always thought of that as a nice sort of visual of, I think, ties together some of the aspects you were talking. Sorry to interrupt. I know we're tight on time. Keep going.
Absolutely. I appreciate that. And that kind of leads well into this next slide, which I realize is kind of an eye chart. So I don't expect anyone to be able to try to like get a magnifying glass and read this. Just want to point out that there's methods to look at indicators of compromise. You can look through, you can use a tool like the MITRE ATT&CK framework or the SANS ICS kill chain to try to figure out what those indicators of compromise might be. And what's interesting about this is you can look through and see things like what Jeff just mentioned about, like, you know, the mouse cursor moving. Okay, well, where they get to in this process? Are they doing some kind of a privilege escalation to be able to, you know, access that system and make those changes, those kinds of things. So I'm going to kind of breeze by this one, which I know it's a lot, so it's probably best to look at the slide maybe offline or go Google those frameworks to kind of look into some more details around what things you might want to look at when you're monitoring for certain indicators of compromise. Other piece, again, sort of already talked about this a little bit, but tuning is very critical. If you turn all these tools on and they're very noisy, you're going to miss the valid or the actually potentially malicious things that might exist in that network traffic with all these other false positives that aren't really legitimate issues. So you got to do some high-level tuning when you first turn this thing on. Generally, they have some kind of a learning mode where they look through and see what's normal, establish that baseline. And then you work your way through doing some additional tuning to make sure that we're constantly iterating and trying to get all these false positives out of the way, so we're focused on things that might actually be real issues, right? So keep in mind that, you know, this tends to be more about the volume of data here tends to be quite a bit higher than what a firewall would give you, right? So if you're looking at all the network traffic through all of your substations, you need to have a way to reduce that down to useful and actionable information rather than just every log that comes through that device. And then continuing on here, you also need to make sure that how does this tool fit with your operational workflows, right? So if you have an IT-centric tool, are you going to rely on your IT department to monitor that at this point? Or are you going to somehow be involved in that process to vet out those false positives, tune it, and act on the potential issues there? Having good training and awareness is important for this as well. And I have a point here about just not all the tools are the same, right? Some tools are very IT purpose-built, some are OT purpose-built, some are a combination. Just having a good awareness of what the tool you've deployed, what its capabilities are. Does it require supplementary information for you to get good data out of it from your OT systems, or is it capable of inherently understanding all that OT traffic? Ideally, you want something that integrates with your existing system. So if you already have a certain platform that you use for other OT cybersecurity related needs, maybe having something that either is from that same vendor or integrates with that vendor very well is something you want to keep track of. And a lot of the times, one of the biggest issues we have in this is that operationalizing these tools is the biggest challenge. It's one thing to go deploy something and put it out there, but to actually maintain it and monitor it is the most difficult part of this process, right? So once you get the tool in place, you have to live with that tool, right? You have to be able to get useful information out of it. You have to keep it up to date. You have to maintain it. You have to make sure that the information it's providing you still has value. So it's very important to make sure that you're planning for that as you go through this deployment, is that you understand how you're going to use that tool on a daily basis once you get past that point. And again, kind of the success of this to make sure you do have that that outcome kind of defined up front, so you know where you're going with this journey, and make sure you actually keep track of that as you're working through this, and make sure that everything is aligned with what your requirements and your needs actually are. And my last slide, now I'm basically out of time here. I just want to mention this real quick, is a case study we did. This is pre CIP-15, so CIP-15 isn't only just got ratified. So this is a project that's been going over the past few years. But we worked with a large organization to help them determine the best solutions for OT monitoring and detection. So this focused on more than just INSM. It focused a little bit on asset visibility and those kinds of things as well on the actual devices. But it was an evaluation design approach where we went through and figured out their requirements, helped them to test out some vendors to figure out which would be the best option for them to move forward with. One thing to note here is there's no one size fits all. Basically, every one of these utilities had different needs, different requirements, different architecture. So all those things would present that they would have a different solution, potentially different solutions needed to best suit their needs. So we really can't say that, okay, this one way to do this is the best way or the only way you can accomplish it, but there are many different options that will satisfy this requirement and also provide value to you in your own OT cybersecurity and your visibility into your networks. So with that, I think I will end my part here, and I'll pass it over to Marcus.
Thanks, John. Marcus, you can grab some slides, and I think we have another Slido coming as well. But let me just, it's not surprising you guys have been at this trying to help. The 1898 has been at this trying to help their customers for some time, and I think having the lens of looking back of where are the challenges is key. And I took a couple notes. One, I think just generally speaking, having an OT behavior specific monitoring is baseline what you want, right? Is being able to understand the OT environment and understand the behavior of what's happening. But I think the biggest lesson learned that we've learned in talking to you and 1898 is and we know this because we have a platform that does this, it creates a lot of telemetry. And so how do we deal with this telemetry? Far more telemetry than a firewall would, right? Because there could be 4 ports on a firewall and 4 dozen Ethernet ports in an enterprise and system bus in a substation. And so understanding that, and then finally, how does this integrate with the larger picture? What's already there? What are your security systems and so forth, right? So hopefully I captured that well, and I appreciate it. There is a quick Slido just as I introduced Marcus here with respect to switches and their ability to exist and lifespan within a substation when it gets deployed. So if you take a look at that, but while you're doing that, I'll introduce Marcus. If you've read any of our Cisco validated designs specific to the utility market, Marcus is likely one of the, if not the main author of those. So he does a lot of testing and publishing and so forth. And so Marcus, take us through a little bit of the, we heard from 1898 with respect to, like what's NERC CIP, what are we being bound by? What are some of the lessons learned and challenges in doing INSM, and how is Cisco going about it? What's our point of view here?
Yeah, sure. Yeah, thanks, Jeff. So, so as Jeff said, I'm Marcus Smith. What we're going to talk about, we're going to start talking about some of the practicalities, I guess, how we can actually especially take what John and Eric have talked about and actually practically implement it in a substation. So what tools have we got? What can Cisco offer? And what have we got to help you, basically? So, okay, so in the middle, we're primarily going to be talking about our asset visibility traffic analysis tool, okay, Cisco CyberVision. But before we get to that point, I think we have to step back and pick up on something that Eric mentioned earlier on in the session, which is about a defensible architecture. Okay, so having a good design, and there are many ways you can leverage the features. So many of the features in networking equipment, so switches, for example, in the substation, there are a lot of native capabilities you can leverage in those platforms to really improve your security posture. Good design, so good design techniques, good design hygiene. As Jeff mentioned at Cisco, I'm part of the team that produce our validated designs. We do have a validated design for substation automation, and inside that we make recommendations, we test different designs, architectures, and we give you the guidance really on what we validated and what we recommend from a best practice point of view. And then on top of that, we can start to layer on some of these other capabilities. So CyberVision is our asset visibility and traffic analysis tool. We can deploy that on top of the network. And then finally, many of you know that Splunk is now part of Cisco, and we're already starting to leverage the capabilities of Splunk for bringing all the data together. So we've got networking equipment, we've got firewalls. If we're using CyberVision for visibility, we need to address the issue of all the data, okay, and remove that alert fatigue, as many people call it. So Splunk, we'll talk about shortly, is the platform that we can use to help us with that as well. So yeah, good design. We've got validated designs on our external website. The links are coming up at the end. But we are using specific products that are built for substations. So switching and routing products that we build and we deploy to a lot of different utilities. We have a lot of different capabilities, as you can see there. We have the capability to deploy our CyberVision product directly onto the switches to be able to do the DPI, the deep packet inspection, to look at that east-west traffic that's flowing across the networking infrastructure in the substation. Okay, so that's a key point I'll pick up on a moment. And yeah, at the bottom, there's a mention of all those security features you get for free in our switches, okay? VLANs for segregation, NetFlow was mentioned as well for traffic monitoring, ACL, so access control list for controlling what's flowing potentially between different VLANs. We've got things like 802.1x and MAC access bypass for controlling what devices connect to the network. So yeah, there's a lot of good functionality that's available in these switching platforms to really improve your posture, security posture, before we then layer on the OT visibility tools on top. So yeah, so our switching portfolio, we've got a lot of switches that are designed specifically for the substation. A lot of security features, as I mentioned at the top right. But at the bottom left, you can see I've highlighted the application hosting. So we have the ability to run small containerized applications directly on our switches. And we are using that to actually deploy our CyberVision sensors. So our CyberVision sensors that are doing the deep packet inspection of the traffic, directly at the switch. Okay, so we can see the traffic flowing through the switch, so the east-west traffic, as well as any north-south traffic as well. So we're actually using the network infrastructure for our to basically be able to monitor the traffic. Okay, so no need to have span ports, no need to have external sensors, and actually you can deploy the sensor from a central CyberVision console. Okay, so again, deployment's easy as well.
Hey Marcus, just while you have that up there for a second, I just wanted to chime in. We got the results of the last poll, which was, essentially how often or what's the lifespan of a switch that's deployed. 79%. I think we have just shy of 200 folks on. 79% of the respondents said 8+ years, right? And so I think that sort of hammers home, our point of view on this is, if we hark back to 1898's session, we have 3 years for the control centers, 5 years for bulk electric, and then that long tail. These switches are going to be in well past that 5-year time frame, right? And sort of that future-proof aspect that you're probably not going to turn it on. You certainly, from a compliance standpoint, need not to turn it on today, but a switch you buy today will likely be in the environment when you need to actually be compliant. Sorry to interrupt. I just wanted to give that update because we had meant to show that on Slido, and we just
okay.
Whoops.
No problem. So so here's a slide. I mean, you can use this as a reference slide. It shows some of our products, DIN rail mounted and rack mounted switches at the top. They're all substation certified. We use many of these in substations, and the key point here is the 62443 certifications. Okay, so our software development lifecycle is certified to the 4-1, and our switching products are certified to the 4-2 standard. So you can purchase these products knowing that they meet a certain validated security level. Okay, so laid down by the IEC 62443 standard, but you're buying a certain capability that's mandated in those standards. Okay, so give you that comfort that there is a level of security capability when you're buying these products. So CyberVision. So if we move now to more addressing the CIP-15 requirements about monitoring not just the north-south traffic, but the east-west traffic, which we've discussed. We've got our assets that sit in the ESP, and potentially in the future as well, other areas in the substation. So we mentioned about other areas being potentially added to the CIP-15 standard. We have our switches, and what we're doing here is we're deploying our software sensor down into the switch, and then we're using it to perform deep packet inspection, so passive deep packet inspection on the traffic that's flowing within the substation. We're able to decode that traffic, and what we do is we do not send a complete copy of the traffic, so like a complete span copy. We send relevant metadata up to our central CyberVision center. So this is our application that receives the data, stores the data, provides a certain amount of analytics, provides the GUI, the communication flow, the asset map, and this is really where you go to look at what's happening on the network, look at any unwanted behavior that's happening in the network, what assets you have, how those assets are communicating, and we'll look at a few example screens shortly, and also reporting. So there are some canned reports that are available within CyberVision, but ultimately on the right, if we're feeding that data up into Splunk, and also we can feed other data up into Splunk, say from our firewalls or from our network infrastructure, we have a much more powerful platform now to be able to search through that data and actually hone down what we want to view, build our own dashboards, build our own queries to generate our own data for certain reports. So addressing that data overload problem that we do see with these type of applications that are deployed in the network for monitoring. Okay, so a few examples. On the left-hand side, you can see the CyberVision sensor actually runs on a whole bunch of our products. Okay, it runs on most of our industrial products, routing and switching, as well as some of our enterprise products as well. So if you're using some of our enterprise products further up in the network, you can potentially deploy the CyberVision sensor there as well. It means that you can, once you deployed your infrastructure, you can actually add CyberVision at a later date. Okay, it's not something you have to do immediately, and it is just a software deployment. But we can get visibility of our assets that's shown here, so we can discover the assets in the network and get visibility of those assets. We can also see how those assets are communicating with each other, and we can also create a baseline. So we can create what we call presets. So we can create a preset to filter down the view. So let's say take DMP3, we can create a preset so we're just looking at the DMP3 traffic that's flowing in the substation. And then we can create a baseline for that preset. And once we have a baseline, the CyberVision will alert us for any changes to that baseline. So whether assets are removed or added, whether there's new communication flows between those assets, or any other type of behavior. Okay, so it's once that baseline's set up, we can then start to be informed of any changes to that baseline. The communication flows, so we can look at assets and we can drill down to specific assets and look at what are those assets communicating with, what protocols are they using. We can then drill down even further, potentially to look at the parameters that are in that particular protocol. So the example here are some write messages, DMP3 write messages, and we can actually start to drill down now and look at what's happening. So if we see a change to a baseline and there's a new communication flow, we can potentially look at the asset, look what it's communicating with, and then drill down to see actually, is that something we're expecting, so we can accept that and accept it onto the baseline, or actually is this some unwanted behavior? Is this some nefarious activity that's going on, and we need to start investigating it much further.
Marcus, just a quick 2-minute warning for you.
Yep, I'm on that. I can see that. I've got a clock. Active discovery. So quickly, some assets obviously don't communicate all of their asset details under normal operational circumstances. So our sensors do have the ability to actively probe or talk to an asset to extract more details from that asset. And to be clear, we are using the native protocol that asset speaks, like DMP3. Okay, we're not port scanning or probing the asset. We're talking to it with its native protocol. Splunk. So once we have all this data, we can feed it up into Splunk. CyberVision does have some inbuilt, obviously, dashboards and reporting, but really, if we feed all of our data up into Splunk, we can use the inbuilt dashboards. So we have built-in dashboards available for just looking at the CyberVision data, and also we have NERC CIP reporting dashboards as well, so pre-built. But the nature of Splunk is it's a data aggregator, and you can basically write your own queries, build your own dashboards, and actually build your own reports as well. Okay, so it's flexible to your needs. And then lastly, just to really say that Cisco obviously has a big security portfolio, and CyberVision is integrated with a lot of our other security products. And the asset data we have in CyberVision, we can push that into many of our other security platforms. Okay, so there is a bigger picture over and above just using CyberVision for that east-west traffic monitoring as well. And lastly, there's a link here for the CVDs, okay, the Cisco validated designs. You can go and get those off our external website, and CyberVision is already a part of these validated designs, especially for the substation automation validated design. And over to you, Mike.
Yeah, thank you, Marcus, for bringing us home. And just want to say you're in a good place. Cisco is very focused on solving these challenges for the utility industry, and have gotten some recognition throughout the market. So let's jump to the some of the resources that are available to you as promised. So I've got some QR codes on the screen. by all means, snapshot those, go there, as we've got, briefings and ways to contact 1898 for all their expertise. And I'd like to thank all of our speakers today for bringing their point of view, their expertise, and sharing that with the group today. We appreciate the participation. There were a number of questions. I think we got back to most of those, but if not, happy to reach out and have further conversations as well. Recording the webinar will be made available to everyone that registered. And on behalf of Cisco and 1898, we do thank you for joining us today, spending your time here. We look forward to working alongside of you and seeing you at future events. So have a great rest of your day.